All right, so here's our third segment for compounds and their bonds. And now we're going to look at starting to name compounds. So we just finished naming ions in segment 2, and we're looking at ionic compounds. Now, we're going to be focusing on binary compounds, which means we're only going to have 2 elements. All right, now ionic means simply we're going to have a cation and an anion, so we know we're going to have a metal and a nonmetal. Now, we're going to write the names just as we were writing the names of the 2 ions. So when it's representative elements, this would be straightforward and easy. If we're talking about group A, it'd be sodium chloride, NaCl. Now, MgBr2, following those rules, would be magnesium bromide. Now, you might have a question there, but what about that 2? It's MgBr2. How does that account for the 2? I told you back in the day here, about 2 segments ago, that the name had to tell me what was there and how many. So magnesium bromide does tell me that there are magnesium there and bromide there, but how does it tell me that there's 2 bromine, right? So how do I account for the 2 bromine? Well, when we're looking at the name, we have MgBr2. Remember, magnesium is a +2, bromine is a -1, and the compound has to be neutral. That means I'm going to take and use 2 -1 bromines to balance the 1 + 2 magnesium, all right? And that's what we're going to do. So naming binary ionic compounds. Again, when it's group A, straightforward. Our biggest concern comes, and the most confusion comes, out of those transition metals. When it comes to transition metals, you're going to have to figure out the charge. Now remember, just like we just looked at the sodium chloride and the magnesium bromide, the compound has to be neutral. No way around that, which means my pluses and my minuses have to balance out. So we know that the transition metal could have a multiple charge situation. We don't know what the charge is. We'll have the Roman numeral sometimes, but if I'm looking at the compound and I'm trying to generate the name, that means it's up to us to generate the Roman numeral. And so what we'll do is we're going to use the anion. Remember, the anion has a fixed value. We know the negative charge of the anion based upon its location in the periodic table. So we can use that negative charge for the anion to figure out what the positive charge of the cation is, thus producing the Roman numeral for the name. All right, and that sounds confusing, and even when in practice, the first couple might be confusing, but hopefully after a few examples, you'll be able to knock it out of the park. All right, so let's give it a try. Let's write the name for CuO. Now, copper we know is a transition metal. We're going to need to know the charge of that metal. It's either going to be +1 or +2. And quite honestly, you don't need to know what the possibilities are because you just need to name this one. So you need to know what the charge of this one is, not what all of the possibilities are. Now we're going to base it on the anion name. So the anion here is oxygen. We know oxygen is in group 6A, which means it's a -2. So if the oxygen is -2, and how many oxygens do we have? We have 1. That means I have a total anion charge of -2. That means I have to have a total cation charge of +2. How many coppers do we have? Well, just 1. That means that 1 copper then has to be a +2. Now that I know the charge of the metal, and remember that's what I needed so that I could name the compound, that number, that positive charge, is going to become my Roman numeral. And so I'm going to have copper 2 oxide. Copper 2 oxide, where the Roman numeral 2 is the charge of the copper. All right, let's try another one. CoCl3. So Co is cobalt. It's a transition metal, and it can have a variety of charges. And again, it doesn't matter what the variations can be. I need to know the charge of this one. So I'm going to use the chlorine, right? Chlorine is in group 7A, and it's a -1. But this time, we have 3 of them. So I have 3 chlorines at -1, which means I have a total anion charge of -3. That means I need a total cation charge of +3. I only have 1 cobalt. That 1 cobalt then has to be a +3 to balance the -3. That gives me cobalt 3 chloride, right? Hopefully that made sense. All right, we'll try a couple more. How about Cu2S? So last time we saw copper, it was a +2. What about this time? Well, sulfur we know is in group 6A, and it's a -2. This time, though, we have 2 coppers. So if I work this backwards, I have sulfur as a -2. I have 1 sulfur, so a total anion charge of -2. That means I need a total cation charge of +2. This time, however, I have 2 coppers. So I'm going to take the total +2 and divide it by the 2 coppers that I have. That's going to give me a charge of +1. So in this case, copper is a +1, and so we would say copper 1 sulfide. All right. Last but not least, Fe2O3, commonly known as rust. But I don't want the common name, I want the chemical name. And so I'm going to again look at iron. We talked about iron when it came to blood. We know it's multiple charge possibility. We need to figure out the charge for this one. So we'll use the anion oxygen. Oxygen is 3 of them, but it's in group 6A and it's a -2. -2 times 3 gives me -6. So I have a total anion charge of -6. I need a total positive charge of 6. So I need cations to be a total of +6, but this time we have 2 iron. So I'm going to take the +6, divide by 2, and that gives me +3. So the iron here has to be a +3. And so the name becomes iron 3 oxide. All right, so again, with non-transition metals, hopefully it's going to be straightforward. With transition metals, we might have to work a little bit to get the charge so that we can get the Roman numeral for the name. But let's give it some more practice, and this time I'm going to mix them up a little bit. Let's write names for the following. So KCl, I'm going to look at this and I'm going to say, okay, is a metal present? Yes. By the way, if you didn't get the flow chart underneath student resources, I have a flow chart for naming. Feel free to pull that down and use that to help you with these names. Right? And it starts off with a top question saying, is a metal present? Now we haven't looked at when we don't have a metal. And if you've noticed, all the metals are written first. So you're always looking at the first element and deciding, do I have a metal or don't I? In this case, we would say yes, potassium is a metal. The next question is that metal a transition metal? The answer is no. That means you simply name what you see. So we have potassium, and then Cl becomes chloride. So potassium chloride. How about Na3N? So again, we look at the sodium. Sodium's a metal. Is it a transition metal? No, it's not a transition metal. So we're just going to name what we see. And we get sodium nitride. Sodium nitride. All right. Third one we have is CrN. So this time, we look at the chromium. Is chromium a metal? It is. Is it a transition metal? It is. Okay, that means we're going to have to add a step here. We have to figure out what the Roman numeral is going to be because that's a transition metal. We'll base it off of the anion. So we look at the nitrogen. We get nitrogen is a -3. It's 1 to 1, so the chromium has to be a +3. Chromium 3 nitride. All right, Sc3P2. So we have scandium. It's definitely a metal. Is it a transition metal? Yes, yes it is. So once again, we're going to need a Roman numeral. So I take the phosphorus, I go to my handy dandy periodic table, and I see that it's in group 5A. That means it's going to be a -2. I have, whoops, did I get that right? No, it's a -3. My bad. It's a -3 for phosphorus. That gives me a total of -6. Now I have scandium, has to make that up, so it's got to be a +6, but we have 3 of them. So +6 divided by 3 gives me a 2. And so we get scandium 2 phosphide. All right, how about PbO? So oxygen is in group 6A. It's a -2. Lead, can I just name it? Oh, that's right. We treat lead like a transition metal. So no, I do need the -2 from the oxygen. That means the lead has to be a +2. And so I get lead 2 oxide. How about PbO2? All right, so once again, oxygen's a -2, but this time we have 2 of them. So that means we're going to have a total of -4. The lead has to balance that -4, and so I make lead 4 oxide. How about Na2Se? So we have a metal present. Is that metal a transition metal? No, sodium's not a transition metal. So we don't have to worry about any kind of numbering. We just name. So we get sodium, and then Se is selenium, but it becomes selenide, sodium selenide. All right, let's try writing some formulas. Remember now, the charges have to add up to 0. So what we'll do is get the charges on the pieces. The cations will either come from the name in the form of a transition metal will have a Roman numeral, or from the periodic table based upon the group number. The anion will either come from the periodic table, or soon I'm going to introduce to you some polyatomics. And the polyatomics will just be a list. That's also under student resources. You can pull that list down and it gives it to you by charge and name and what the formula is. Once you have the charges, you can balance the charges one of two ways. There's the just adding subscripts until you get the numbers to add up, or you can do what's called the crisscross. I'll be showing you how to do the crisscross method. All right. But I'm going to go through both methods here. So we're going to do the formula for calcium chloride. We'll do it one way mathematically, and then I'll do the crisscross. And you'll see either way you go, you end up with the same answer. So whatever's most comfortable for you is what's going to work. We know that calcium is a Ca plus 2 because it's in group 2A. We know chlorine is a minus 1 because chlorine's in 7A. Now if I simply add those together, then I have a plus 1 charge left over. So I can either add more calcium, which is plus 2, that wouldn't make any sense since I have a positive charge left over, or I can add more chlorine to then take away from that plus charge. And of course that's what I'll do. So we're going to add another chlorine to that. So if I do it mathematically, then I get 1 calcium at plus 2, trying to get there it goes. Calcium plus 2, and then chlorine was a minus 1, but I have 2 of them, right? So mathematically then, once I work that out, this becomes CaCl2. Okay. Now, if I want to do it by crisscross method, all I have to do is back up a little bit to there. And what I'm going to do now is I'd simply write the formula as it is. So we'll have Ca plus 2, Cl minus 1. And now for the crisscross method, I'm going to ignore the signs. I'm going to take this 2, I'm going to crisscross it to here. I'm going to take this 1, I'm going to crisscross it there. Now, no matter which way I do this, I do not write 1s. And so I end up with Ca, Cl2. And so whether I do the crisscross method or if I just do it by math, either way I come out with the same answer. All right, so hopefully you followed along with that and you're good to go with writing some formulas. So let's give it a whirl. Lithium sulfide. So I'm going to go to my handy dandy periodic table. I'm going to find lithium. We know lithium is a metal. It's in group 1A, and so it's going to be Li with a plus 1 charge. Sulfide we know is sulfur. That's in group 6A, and that's a negative 2. So in order to get those to balance out, I can either crisscross them, or I can simply add them together and then figure out which subscripts to add. But either way, I end up with Li2S. All right. How about tin 2 oxide? So tin 2 oxide. So I'm looking at tin with Roman numeral of 2. That tells me that it's Sn with a plus 2. Oxide is going to be at O minus 2 because it's in 6A. Now I'm writing this out because if you do use the crisscross method, right, and we crisscross these, that 2 goes here, that 2 goes there. What you're going to have to do next is reduce it. Remember, it's always the lowest formula, the lowest multiple formula. So if I just do it by charge, plus 2 minus 2 gives me the right answer. It's going to be SNO. But if I crisscross them, I get SN2, O2. And if that's the case, then what I'm going to need to do is then reduce them to the lowest possible multiple. Either method, I should end up with SNO. All right, how about tin 4 oxide? Well, here we're going to play the same game, right? So tin has got a cation charge of +4, so it's Sn +4, and then O -2. And when I crisscross those, I get SN2O4, which reduces to SnO2. All right, hopefully that's going well. How about magnesium fluoride? So here I'm going to get the charges for the two pieces. We have magnesium is Mg with a +2. Fluoride is fluorine with a -1. I crisscross those and I get MgF2. How about copper 2 sulfide? This is what chemistry makes most students do. You're going to get copper 2, so it's Cu with a +2. Sulfide is sulfur, that's a -2. +2, -2, they cancel out, or if you want, you can crisscross and reduce, and it makes you want to cuss. CuS. How about iron 3 phosphide? So we get iron 3 would be Fe +3. Phosphide, P -3. You can see they either cancel out or you can crisscross and reduce. How about gallium nitride? Yeah, so we have Ga is +3. It's in group 3A. It's underneath of aluminum. And then nitride is nitrogen. So that's going to be a -3. So -3 +3, they balance out to be GaN. Right? How about iron 3 sulfide? So iron is a +3 because of the Roman numeral. Sulfide is in 6A. That's a -2. If I crisscross them, then I get Fe2S3. If I try to do it mathematically, then I can see I have a +3 and a -2. I add a -2, so now I have two sulfurs. That's a -4, which means I have to add another iron. So you can see mathematically you can work your way up there, but you'll finally come to Fe2S3. All right, so that was naming ionic compounds. Now, I warned you a little bit before, we have these polyatomics lingering. If you've not gotten that download yet, or you didn't download that thing from the student resources, now's the time. So we're going to stop the segment here. This will give you the chance to get that polyatomic sheet if you didn't yet. Also, you want to have that naming flowchart and potentially a periodic table. Those are the three things you're going to want for naming if you haven't gotten them out already. All right, so we'll pause here and then we'll start segment 4 with polyatomic ions. All right, stay tuned.